All right, boys and girls, welcome back to the drive-thru. Shout out to Gabby. She's got her first and only track meet. She's running the entire track meet by herself. Okay, this is number one from the back of the Law of Cosines worksheet. Okay, and number one is an ambiguous case. So, why is it an ambiguous case? Because you have an A-S-S situation, and you have an acute angle for the A. So my first piece of advice is always to rewrite this triangle with the angle that you know in the bottom left. That might not be necessary, but I'm telling you, I can't do it without it. Because every time I write these, I have to orientate my triangles the same way so I can figure out which side is hinging. Okay? You got an 8 here and an 18 in between, so now we can write in. This is a C, so that's a little c. 8, let's see, is across, let's see, angle B is across from the missing one, and that makes that A, and that makes that little a. Okay? Now, the people that memorize the test tend to forget about this instantly. My suggestion is just to remember that I have to test something and compare it to the height. How do I find the height? Just using good old-fashioned SOHCAHTOA. So according to 25, what's the H? Is it opposite, adjacent, or hypotenuse? It's opposite. And this 18 is known. What is that? That's the hypotenuse. So sine of 25 is H over 18. Can you do 18 times the sine of 25 for me, Gabs? Keep going. Okay, that's fine. We're going to use 7.6, but I'm going to always write out more than I need. All right, so look. Is that 8 going to make a triangle? Meaning, will this 8 touch the base? Yes, it will, because it's bigger than that. Is it smaller than this side? So it's going to touch it twice. It's going to touch it just barely to the right and just barely to the left. Does that make sense? This segment is swinging. I'm going to touch it there and there. Okay? So now what I do is I always rewrite my two scenarios. And I guess it's really important that you understand, look, this hasn't changed, correct? This hasn't changed, and this hasn't changed. I also want to remind you that if you have no idea about the ambiguous case and you just know how to do law of cosines, you'll still get completely half of this right. You're just going to miss out on the other half. All right, so now we can use law of cosines, I think. Actually, I can use law of sines to find the missing angle. I just got to know that it's not going to be the obtuse angle. Okay? So, sine of 25 is to 8. Like sine of, let's see, what's across from the 18? A is to 18. So sine of A is equal to 18 times the sine of 25 divided by 8. Could somebody do 18 times the sine of 25 equals divided by 8 equals? No. Is that A? 0.95089. Okay. Take the sine inverse of both sides. And you get A equals what, Gabs?
71.9.
Thank you, Sid. 71.969. Okay? All right, so this angle A is 72.0. That's rounded to the nearest tenth. What you have to understand is that is right here. Okay? And this pink triangle is isosceles. So, to find this angle right here, you're finding that angle right there. How do you find it? You just take the supplement of the angle you just found. So 180 minus 72.0 is 108.0. I need to write 0.0 so I indicate to my audience that I've rounded. Okay? All right, so now, what's this angle? It's 180 minus 25 minus 72. Okay? What's this angle? What is it? 83. All right, come on. You guys have got to do a better job on your calculators. It's screwing these videos up. And then people pause the videos and wonder what's going wrong. Okay? Is 47 correct? Okay, so now we got to find the missing side. We'll call this, let's see, what is it across from? This is B1, and this is B2. So you just do sine of 83 is to B1. Like, I always use the given one, so sine of 25 is to 8. Okay? Cross multiply and divide. 8 times sine of 83 divided by sine of 25. Sure. 18.92961, so we're going to call that 18.9. And B2, we will do sine of, instead of 83, what will we have? We'll just have a 47 now. So sine of 47 is to B2, like sine of 25 is to 8. And those are your two sets of possible answers to this question. Got it? All right, you asked me before, why won't your calculator give you an obtuse angle for law of sines? Okay? So, sine, you end up getting like sine of A is 0.7921, let's say. Well, go ahead, find A. What is it? What is it? Okay, so that means the ratio between the opposite and the hypotenuse in this triangle right here is 0.7921, right? So let's just, like, you could put this. This is 0.7921, right? And this is 1. No, this would be 1. Does that make sense? Does that make sense? Erase that. No. Opposite. 0.7921 and 1. Sorry. Got it? So this point right here is something, comma, .7921. So far, so good? Well, here's the problem with reference angles. I want you to consider this triangle right here. Okay? And this is 52. This reference angle is 52.382. Okay? Now, what is this point here if those two triangles have been reflected? Negative x, comma, positive 0.7921. And this is still 1. Do you understand what's going on here? Now, what would the sign of this be? It'd be 0.7921, right? The problem is that angle is not 52.382 degrees. What is that angle? The reference angle is 52.382, but what is the actual angle? What is 180 minus 52? Give that to me. 128 point. Gosh, you guys are killing me. 127 point. All right, so look, this is great. This ties up everything we've learned in this chapter. First of all, in your calculator, do sine of 52.382. It's about 0.7921, right? Now, do sine of 127.618. It's the same thing because of the reference angle idea. And that is why your graphing your calculator will not give you an obtuse angle, because it doesn't know that you're referring to the reference angle. It's just strictly thinking SOHCAHTOA. Does that make sense? It just answers your question. It's hard stuff. Okay, it's a good question. It's a long video. Boom!